Thanks for joining us. So I'll be talking more about how we use Kafka to manage risk here at WePay. Um, to start off, this is the agenda we'll be following in this presentation. So we'll talk about how Kafka is a backbone for a lot of our risk infra services. I'll also be talking about risk reviews in general, and then risk reviews powered through Kafka. Then we'll move on to the risk TSL, which is the risk domain specific language that we've designed here in the risk engineering team at WePay. This will give you an idea about how we define what gets prioritized. At the very end, we'll go over the overview of each components that come together that will help us prioritize risk reviews. And at the very end, I'll leave some time for questions. So yeah, let's get started. So Kafka is pretty integral to a lot of our risk services here at WePay. To give you an overview, we have, this is like a service map of all the services that interact with Kafka. I'll just go at a very high level, what we use Kafka for. To start off with, we have these real-time event sources, which are nothing but, MySQL or Cassandra tables. And we use CDC. For MySQL, we use Debezium. So all of these events are then published onto Kafka. And then we have this risk aggregation pipeline. Basically, this pipeline has a bunch of services. One of them is the risk decoration service, which will then write events into Kafka, which is read by Cloud Data Flow and then written to BigQuery. So the risk aggregation pipeline uses Kafka for aggregation purposes. Then we have the risk review pipeline. The risk review pipeline basically looks at review requests for entities that we want to review for risk purposes. And then we have a bunch of services within the review pipeline, like the queue manager, the decision engine. The decision engine is basically the service that decides what we should be doing with the review request. And it interacts with a bunch of other services like the machine learning models. Here at WePay, we have the vendor services that help us decide if an entity is fraudulent or not. And the RBIT services, which is like the risk bit information that we receive from our partners. Then we have the risk graph database pipeline. Essentially, we use in-memory graph database for linking purposes. So anytime a fraud is committed with one of our merchants, we try to link that kind of fraud with other merchants through a bunch of data points. So, the risk graph database pipeline, converts these events and converts them into edge events and write them back into Kafka. And these edge events are then consumed within indexing pipeline, which will index it into a graph. We also have this data deletion service for CCPA requirements. Essentially, any service that comes up registers itself with the data deletion service, and then when a deletion request comes in, the subscribe service is notified through Kafka about a deletion request. So at a very high level, we use Kafka a lot for event streaming purposes. We also use Kafka for acting on decisions or managing risk overall at WePay. At the very top, you can see we also have a data warehouse and batch processing source in the form of BigQuery. So anytime you have a graph schema change, or anytime you have something that is changing and you want to ingest everything in batch, we use data flow to actually read from BigQuery and write events into Kafka. So now I'll be going into two major use cases of Kafka within the team. One is the aggregation pipeline. Again, like you have events stored in MySQL for entities, and then through Debezium they're written to Kafka. Then we have the risk decoration services. So this service is essentially going to decorate or add more information on a given event. So let's say an event comes in with a credit card ID or the user ID. We now need to add more or decorate that event with the first name or the last name or the credit card bin or the last six of the credit card. So all of that is done through the decoration service. So now you have these decorated events. We then leverage Apache Beam with the Cloud Data Flow Runner to actually aggregate those events, and the aggregated events are then emitted periodically. These aggregated events are then converted into a big table persistence event, and eventually through data flow we write those into Cloud Bigtable. So we've leveraged data flow to write into Bigtable is only because of multi-region support. We need to write into two Bigtable tables in different regions. That's why we leverage Cloud Data Flow for that. Now, quickly going over the graph database indexer pipeline. So again, we have these events coming in through the Debezium. We have the raw entity events come in. We have the config for each raw entity, which tells us, what vertexes to extract and what edges to create from those vertexes. And then we write those edge events back into Kafka. Periodically, we'll also index snapshots of the indexed files, and then we have the linking service, which will actually read those edge events and then index them into the graph database. Here you can see we also use persistent disks in Google Cloud. This is to store the indexed files. These indexed files, will actually power queries by the client. And at the very top, you can see that, again, like for schema changes or when we want to add new data sources, through Airflow, we would trigger batch jobs into BigQuery and then publish those raw events back into Kafka. So Kafka acts as the source of data for the graph indexing purposes as well as the aggregation pipeline. So yeah, this is the whole flow of how we index or create the graph using Kafka. So talking about risk reviews, what does reviewing entities mean at WePay, right? So, the question arises, what are we exactly reviewing? So we review payments that are coming in, we review payouts, we review credit cards, and we review merchants that are onboarded onto our platform. And when do we exactly review them, right? So one is at payment auth. So basically payment auth means when you use your card or do a payment, we want to validate if there's enough funds to actually cover the amount that is paid. And the amount that is authorized is then put on hold. So you can't use those funds till it's captured. So we also review during payment capture. Here, what it means is the funds are actually transferred from the payer to payee, and the payment is no longer in the pending state. So you've reviewed it, and now you actually moved the money. We also review during credit card authorization. So this is basically when you want to validate a card without actually holding funds, right? So imagine you are adding a credit card, onto a wallet or something. It's more like a $0 auth, but you want to just validate if the card number is valid and everything is valid about it. And we also review during payouts and chargebacks and during merchant onboarding. So this is mostly for KYC purposes. After a merchant is onboarded, they've uploaded their KYC information, we try to review those merchants. And obviously the question arises, why do we exactly review these entities? Obviously for fraud. So there could be payer fraud, account takeovers, merchant fraud, and also for compliance reasons. So there's anti-money laundering, sanctions, terms of service violations, and other reasons like card testing attacks. And how do we review these entities, right? So there's two ways, obviously synchronously through credit card authorizations and payment authorizations. And we also review them asynchronously through payment capture, payouts, and yeah, I think these are two main sources how we actually asynchronously review entities. So these were like the basics about, what are we reviewing, why are we reviewing it, and how Kafka is like the backbone for a lot of services. But now just diving deeper into risk reviews powered through Kafka, right? So how are we using Kafka? So risk reviews happen at different checkpoints, and checkpoints are nothing but points in time where we feel there's a need to review an entity. So for example, post KYC upload, at payment capture, at payouts, or at payment authorization. We want to review payments, we want to review merchants, we want to review credit cards at these checkpoints. And the asynchronous review process, which I mentioned earlier, is totally powered through Kafka. So what this means is the review request and the response is all done through Kafka. So acting on decisions is through Kafka. Initiating a review is also done through Kafka events. And Kafka helps us in a lot of ways. It's a scalable event streaming platform. It's high throughput with low latency. The concept of parallelism through partitions in a topic is pretty powerful. We leverage that in the upcoming slides. You'll see how we make use of that. And it's a mature technology. It has support with multiple client libraries in different languages, and it also integrates well with Apache Beam, which is part of our stack. And there's a bunch of ways Kafka doesn't help us in its raw form. One is bursty traffic. So if imagine there's a viral campaign going on and there's burst of payments coming in for that particular campaign. Payouts, these happen in batches, right? At the end of the day, we pay out a bunch of money to merchants, right? So these are bursty traffic, right? And there's one more, which is like the same day settlement, right? So you have payments made by 8 p.m. Eastern time, which is 5 p.m. Pacific time, that need to be deposited into the merchant account by midnight. So what you have in same day settlement is thousands of payouts to merchants that need to be reviewed. And this usually happens in batches. So what we need is a way to actually prioritize such time sensitive reviews. And Kafka in its raw form doesn't really help you, worry about scenarios where there's head of line blocking, or if there are stuck reviews at the in a given partition before a particular review that needs to go in first. So what are the challenges we are facing is the volume of requests increases. We need some sort of queue management, right? To prioritize time sensitive reviews. You need capabilities for our stakeholders to dynamically add rules to prioritize reviews. We need to streamline reviews into multiple queues based on set of features like high profile campaigns, point of sale devices. We also need some sort of visibility into the existing flow of reviews that are flowing in and out. So we need some sort of granular visibility into the whole system that is actually responsible for reviewing entities, right? And because of all of these challenges, what we've done is we've defined a domain-specific language. We call it RISC BSL, and this is something which will help us define what gets prioritized, right? So you have a concept of priority rules. The rule basically has 4 fields, which is name, description, expression, and priority. And a rule expression can consist of a property of a review request. So it could say a platform ID, it could use a payment amount, it could use the merchant address or the payer first name, or it could make an external service call to get more information on the payment or the review request. So to give you an example, take a look at this example rule, right? So we have this high priority platform. So we want to prioritize reviews for payments made to this platform, or payments made on this platform. So what you have as an expression is the platform ID, which is part of the review request object. And you say that if the platform ID is one of these, then you want it to be a high priority review. A different example could be for Chase direct deposit accounts, right? What we are trying to say is if the money is going into a Chase direct deposit account, we want it to be prioritized, right? So the expression is, if the checkpoint, is payout and the bank data. So basically you're giving a bank account ID and you're trying to see if it is Chase. So the bank data function is responsible for getting the bank account information, and you're checking if it's a Chase account. So these are examples of 2 different rules that we apply on review requests and using the RISC BSL. So At a very high level, the risk DSL is used to define signals, rules, and decisions. And the DSL consists of two main components. One is the risk function, and the other one is the context. The context is something which is part of the review request itself. So it's like a field or a part of the event record. And the risk function is basically useful for getting information from different sources. So in the previous example, you saw the bank data was a risk function, right? So what you're doing here is providing it with a bank account ID, and based on the response, you're checking if the isJ's value is set or not. And this is an example of risk function that would get bank data given account ID. We also have decisions using the risk functions. So for example, you have a particular rule which says, okay, if this rule triggers, you want to set reserves for this merchant, or you want to put this merchant or this payment into manual review. You want someone to take a look at it. So you define such actions that could have happened based on the triggers, if the rule triggers, and these are defined using risk functions, which is part of the risk DSL. So developers can really create these new functions that will help risk analysts to actually dynamically create new signals and rules. And this is pretty powerful because these functions are then used to define trigger points, or also define sources of where you would get the data from, and everything is under the hood. The risk analyst shouldn't know where the data is coming from, and the developer is making lives easier for everyone to actually define new rules. So at a very high level, we define priorities, three priorities, which is high, medium, and low. The higher priorities naturally would mean they would be allocated more resources. And earlier, as I mentioned, that the concept of parallelism in the form of partitions is pretty powerful. So the number of partitions and consumers for higher priority topics are more than the medium and the low priority topics. So this small diagram here could give you a bit of idea where you have a bunch of these review request events coming in, and they are produced into the specific topic, each having different sets of partitions. And each of these topics then have different or more number of consumers as you go higher in priority, right? So more number of resources allocated to these topics, and higher one gets obviously preempted compared to the lower priority topics. So now we'll talk about how they're prioritized in general, right? So the prioritization flow works as you define what gets prioritized using a DSL. You execute those rules when the review request is ready to be reviewed. And then you reduce the rules. So what that really means is, let's say a bunch of rules triggered. A simple reduction would mean that, okay, out of all the rules that triggered, which one was the highest priority is the one that you would assign a priority to that review request. You could also have complex implementations where you could have weights for each rule and then come up with the right weight that you want to assign to the review request. And at the very end, you would produce this new prioritized review event into a dedicated Kafka topic. So to summarize, the challenges we are facing and how we develop this new system using on top of Kafka is, again, you have these entities at the top that you want to review at different checkpoints. And these events would then be produced into Kafka. Then you would have these review request events flowing into the review event prioritization module. So the raw requests are then prioritized, and they use the priority rules, right? So these rules are stored in a different risk signal and rule definition service. And occasionally we will cache those rules and apply those rules. Based on the reduction process, these prioritized rules would then trigger an event to be prioritized. And the prioritized review request event is then processed into the risk decision engine service. And the risk decision engine service would then obviously use a bunch of signals and rules to come up with a final decision as to what we should be doing for this review request. So for example, For payments, it could be passed, it could be failed, it could be put into manual review. There could be a bunch of actions we could perform on the merchant, on the payment, based on the decision event. And the decision event is again a Kafka event. The decision event processing module would then consume the decision event and act on it. If you see, we also leverage the Kafka Connect BigQuery, which is developed at WePay, to actually write or stream these events into BigQuery. And we also use the Cloud Data Flow Apache Beam job to actually write these events back into Cloud Bigtable for API purposes. And all of this fits in together pretty well because you also get visibility into the system through the job tracking module that you can see at the very center. This job tracking module is pretty useful for actually diving deeper into what part of this whole system is taking more time. You get visibility into the system as to how long it's taking end to review particular prioritized jobs. You always have the option for the risk analyst at the very top to trigger review request events. These would be always higher priority compared to the automated events. And the rules are defined by risk analysts, which would help us, dynamically add those rules, priority rules, as I call it, to prioritize events as and when they flow through. So this is how the whole end-to-end review request works. We define how things get prioritized and why we leverage, Kafka partitioning to actually scale or allocate more resources towards different priorities. So in conclusion, risk at WePay uses Kafka extensively in a bunch of services. We are, Kafka first in some sense. It's a really powerful technology, and especially when you want to do a lot of asynchronous processing. And if where it doesn't really work, you always have an option to build solutions which are business specific, on top of Kafka, like we did with the risk DSL to prioritize reviews and whatnot. So with that, I'll obviously thanks to everyone in the risk infra team here at WePay, and thank you all. Open for questions.
Yeah, Viraj, I think there are 3 questions which came in the chat. The first one is from Shengyu. What is indexing service in terms of business?
Yeah, so to elaborate on the indexing service, what we really want is we want a way where we are ingesting or creating the graph, of all the events or entities, as I like to call it. This includes fraudulent entities also. So the indexing service is technically responsible for creating the graph, indexing these edges into the graph, and storing snapshots occasionally. So the service that is actually responsible for serving, client requests to find or link fraud on a platform, we just pull in those files from the indexing service.
Okay. The next question I have is from Darshan. Do you guys support custom reviews as per merchant requirement?
I don't think so.
Okay. The next question is from Rishi. Which computing platform do you use to run computations?
So I'm not really sure what they mean by computations there. Maybe we can answer that at the very end if we get more clarity on.
Yeah, sure. I think the next question I have here is for async processing, when do you actually get to apply output from the review request?
So the review, can you repeat the question?
For async processing, when do you actually get to apply output from the review request?
Right. So we also, as I mentioned in one of the slides, we have decision events that come in, which are like output of reviews. And these events are consumed obviously as soon as they are ready for action. So after the review process is over, the decision event is produced into a Kafka topic. We have a bunch of consumers which are ready to consume those events and act on it. So it's all through Kafka-based events.
Okay.
Asynchronous, yeah.
Okay. I think the continuation of that question is, would the actual process which was triggered wait for the output from an async review request before proceeding?
No, so it's all event driven.
Okay.
So we don't really wait for the review process to be over before we can act on it. So we keep triggering new events as and when we want to review that particular entity, and we just wait on the decision event to actually act on the response of the review request.
The next question is, do you use Kafka for synchronous operations too, like authorized credit card? If so, could you share more about it?
So right now we don't. Yeah, and as of now, we don't really leverage Kafka for sync processing.
By computation, I mean, this is you asked about what computing platform, right? I think Rishi replied back with that as like, by computation, I mean ML models, etc. This should be the platform which is pulling data from Kafka, doing compute work and writing back results to Kafka.
So we are a Kubernetes based like as far as containerization and deployments, we use Kubernetes. But if the question is around like where these things are hosted, I would say we are on Google Cloud right now.
And Viraj, are you using plain vanilla Kafka clients, or are you using Kafka streams to do the compute? Or are you doing other Python types of things?
Right. So we use vanilla Kafka, and we've developed our own libraries internally to help us with shared operations.
I think what my next talk will get into how Kafka can enable horizontally scalable stream processing would be this is a good segue actually.
Yeah.
So no matter what you write, as long as you're using Kafka clients, you get to take advantage of that scalability.
Yeah. Yeah, I think I'll read out last two questions. Like, are there any alternatives you have considered before using Kafka? Could you share some pros and cons of Kafka competing products?
So I think we started off with Kafka. It fit pretty well with the way we were, expecting the latencies and interaction with our existing stack is concerned. We also are moving or use, for sync processing, gRPC, and expose these RPC methods for our clients to interact with. But yeah, Kafka's always worked for us. As I mentioned in the presentation, like for things where we are facing challenges, Kafka, we were trying to see if building solutions on top of it really help us, and it did do. I mean, based on depending on how you design your service, it helps you, face or handle a lot of different kinds of challenges.
Okay. I think that's pretty much it for the questions. Thanks, Viraj. Thanks for the sessions.
Thank you.